Hello everybody, myself Prashant Mukhopadhyay, faculty member, Electrical Engineering Department, Greater Kolkata College of Engineering and Management. In our Power Electronics and Drive class, in the last class we have discussed about HVDC, that is high voltage direct current transmission system, where how power electronics is being applied. So today we'll discuss about the static circuit breakers. So it is maybe one of the static circuit breaker is also one of the applications of the power electronics. In this unit 5 actually says DC and AC drives. So we have so far discussed about this speed controls of DC motors, AC motors, and so also high voltage DC transmission systems, and also now we'll discuss static circuit breaker. In static circuit breakers, that is one of the another applications of power electronics. Thyristors actually used, and thyristor being a bistable device is widely used for switching of power signals owing to their long life, high operation speed, and freedom from other defects associated with mechanical and electromechanical switches. So that's a very big advantage of this using thyristors as a switching device, so particularly since it is used widely because of it's a long life operation, high operation speed, and freedom from other defects that is associated with mechanical and electromechanical switches. So firstly we'll discuss about this AC circuit breaker using ACR. Basically it is a static AC circuit breaker. So this is the figure of a static AC circuit breaker where two ACRs are used, ACR 1 and ACR 2, for making and breaking an AC circuit. And the input voltage is alternating, and the trigger pulses are applied to the gates of the ACRs, okay, and through the control switches. Basically this is the control switch through which the trigger pulses are applied at the gate of the thyristors, okay. So resistance R, that is provides this resistance R is provided in the gate circuit to limit the gate current. So basically this R limits the amount of the gate current applied in the gates of ACR 1 and ACR 2, okay. And resistor R1 and R2, this resistor R1 and this R2 are to protect the diodes D1 and D2. So this protect this diode D1 and D2 respectively. So what we are finding here, this resistor R in the common for the gate circuits connected in series with this switch, so control the gate current for applied for both ACR 1 and ACR 2, and this resistor 1 and resistor 2 are in series with this diode 1 and diode 2 to protect them, okay. Now for starting the circuit, when the switch S is closed, ACR 1 will be fired at the beginning of the positive half cycle. So when this switch is closed, ACR 1 will be say switched on at the beginning of the say positive half cycles, and the gate trigger current is assumed to be very small, and because during the positive half cycle ACR 1 is forward biased, and it will turn off when the current goes to the zero value, okay. So this one actually so goes to the zero value. As soon as ACR 1 is turned off, ACR 2 will fire since the voltage point is already reversed and it gets the proper gate current, and the circuit can be broken by opening the switch S. So opening of gate circuit poses no problem, as current through the switch is small, and as no further gate signal will be applied to the ACRs when switch S is open, the ACRs will not be triggered and the load current will be 0. The maximum time delay for breaking the circuit is 1/2 cycle, okay. So that is actually the static AC circuit breaker, and thus the several hundred amperes of load current can be switched on off simply by handling gate current of a few milliampere, so by an ordinary switch. So this above circuit is also called a static contactor because it does not have any moving part. So that's why it is called static contactor or static circuit breakers. Okay, so once again I will be repeating this. This is the static AC circuit breakers where through switch S, SCR1 and SCR2 are say being used, two SCRs, one for making and another for breaking the circuits, and gate is being supplied, say signal is being given to the gate of SCR1 and SCR2 by closing this switch S, and in switch S, in series with this switch, resistor R is there, which limits the gate current of the SCRs, and other two resistors R1 and R2 are connected with say diodes D1 and D2 for their protection. Okay, so at the beginning of the say when AC is closed, SCR1 will be at the beginning of the positive half cycles, so the gate trigger current is assumed to be very small. In that case, because during the positive half cycle of SCR1 is the power bias, and it will turn off when current goes to the zero value. And as soon as SCR1 is turned off, SCR2 will fire, and since the voltage polarity is already reversed and it gets the proper gate current, the circuit can be broken by opening the switches, and opening of the say gate circuit poses no problem, as current through this switch is small, and as no further gate signal will be applied to the SCRs when switch S is open, the SCRs will not be triggered and the load current will be zero. So the maximum time delay for breaking the circuit is 1/2 cycle, and the several hundred amperes of load current can be switched on off simply by handling gate current of a few milliampere by an ordinary switch. And this above circuit is also called a static contactor because it does not have any moving part. Now we come to the discussions of the DC circuit breakers. This is also a static DC circuit breaker. This is the circuit. Okay, this is one of another SCR applications, that is static DC circuit breaker. So this as shown in this figure. So capacitor C provides the required commutation of the main SCR. So actually, since the current does not have a natural zero value in a DC circuit, when the SCR1 is in conducting state, the load voltage will be equal to the supply voltage, and capacitor C will be charged to resistor R. Okay, so this will be charged. Actually, this is the process. Okay, so as soon as the capacitor C provides the required commutations of the main SCR, since the current does not have any natural zero value in a DC circuit when SCR1 is in conducting state, and the load voltage will be equal to the supply voltage, and the capacitor C will be charged to resistor R, and the circuit is broken by turning off SCR1, and this is done by firing SCR2, and this will be fired. So as a result, then this will be like this. This current will flow in this way, and this will when this anode current or conduction current, this current will be opposing this conduction current, and when this will be more, so the SCR1 will be off. So because of this is DC circuit, no natural zero phenomena will happen. So this by firing SCR2 called auxiliary SCRs, of course, capacitor C discharges to SCR2 and SCR1, and this discharge current is in the opposite directions to that flow through SCR1, and when the two become equal, SCR2 will turn up, and now capacitor C gets charged to the load, and when the capacitor C gets fully charged, the SCR2 turns off. So this the circuit acts as a DC circuit breaker, and the resistor R is taken of such a value that current through R is lower than that of the holding current. Okay, so basically this is about this circuit breaker, static circuit breaker. Once again, I'm telling you this DC circuit breaker and this AC circuit breaker. As I told you, this AC circuit breaker, this is static circuit breaker. Since this switch, there is no static rotating or moving part, and ACR is a very useful and effective device for switching power signals due to their long life, high operation speed, and freedom from other defects associated with mechanical and electromechanical switches. And this is a static AC circuit breaker circuit, so two ACRs are being used, one for the on and one for the other for the off purpose of this circuit. And this is a switch is in series with R is provide the gate signals for turn on this thyristor 1 and thyristor 2 wherever it is required. And this resistor R1 and R2 are there to protect this diode D1 and D2 respectively. And for starting, when the switch AC is closed, ACR1 will be fired at the beginning of the positive half cycles. The gate trigger current is assumed to be very small, and because during this positive half cycle ACR1 is the forward bias, it will turn up when actually the current goes through the zero value, and as soon as ACR1 is turned up, ACR2 will fire since the voltage polarity is already reversed, and it gets the proper gate current. So the circuit can be broken by opening the switches, and opening of the gate circuit poses no problem, as current through this switch is small, and as no further gate signal will be applied to the ACRs. When switch AC is open, the ACRs will not be triggered and the load current will be zero. The maximum time delay for breaking the circuit is one half cycle, and the several hundred amperes of load current can be switched on or off simply by handling gate current of a few milliampere by an ordinary switch. And the above circuit is also called static contactor because it does not have any moving part. And another circuit is the DC circuit breaker. It's a static DC circuit breaker switch, actually DC circuit. And here also capacitor C provides the required commutations of the main ACR, okay, ACR1. And since the current does not have the natural zero value because it's a DC current, when the ACR1 is in the conduction state, the load voltage will be equal to the supply voltage, and the capacitor C will be charged to its through the resistor to the full voltage, actually supply voltage, and the circuit is broken actually by turning off this ACR1, okay. And this can be done by firing ACR2, that is, which is known as the auxiliary ACRs, okay. ACR2 is the auxiliary complementary ACR, and capacitor C discharges to this ACR2 and this path, in this path, and it will oppose this discharge current will oppose the conduction current, and when it will be equal, so this current to ACR will be zero, okay. And the discharge current is in the opposite direction to that flowing to ACR1, and when the 2 becomes equal, ACR2 turn off. And now this capacitor C gets charged to the load. When the capacitor C gets fully charged, the ACR2 will be turned off. Just circuits act as a DC circuit breaker because when it is fully charged, so actually this will be reverse biased, and as a result this ACR2 will be off, okay. So actually this the circuit acts as a DC circuit breaker, and a resistor R is taken of such a value that current through R is lower than that of holding current. This resistors R, okay. So the current through this will be less than the say holding current, and such a case whenever this conduction current is come below the holding current, and we know from the very very characteristics of the SCR will be turned off. Okay, and we have learned this, we have studied this in our commutation, different commutation methods. So how this conduction current can be taken back or taken below this holding current to make the SCR off. Okay, so that's the principle, and this principle is being applied in the static circuit breakers, whether it is AC or DC. Either natural commutation process or say forced commutation process is being applied to make break the circuit. And since this type of say SCRs are being used for making and breaking the circuits, so it's known as the static circuit breakers, where no moving part is there. Now we'll start a new topic, particularly another major application of power electronics, and this is UPS, uninterruptible power supply. So, and what is an UPS? Basically, an uninterrupted power supply, or UPS, is defined as a piece of electrical equipment which can be used as an immediate power source to the connected load when there is any failure in the main input power supply, input power source, basically. So once again, I'm repeating, an interruptible power supply, or UPS, is defined as a piece of electrical equipment which can be used as an immediate power source to the connected load when there is any failure in the main input power source. So basically, we are all familiar with the UPS. Those who nowadays everybody is using say desktop computer, and it is say supplied through UPS. Basically, why this is? Because when you are doing it your desktop or laptop, whatever it is, so if it is desktop, so particularly when we are doing something, so in the meantime all of a sudden power is gone. So in that case, whatever the work I have done with the desktop, so that to be saved, and if it is not already saved, so if it's required to be saved, and for that purpose sometimes is required, power backup is required, and that power backup is given through this UPS. So in a UPS, the energy is generally stored in flywheels, batteries, or supercapacitors. When compared to the other immediate power supply systems, so UPS has the advantage of immediate protection against the input power interruptions. So it has very short on battery run time, and however this time is enough to safely shut down the connected apparatus, computers, telecommunication equipment, etc., or to switch on a standby power source. So as I told you, so not only to save the say work done, and to make the say off the switch, make the off of the system, so you require certain time. Okay, so that it cannot gun all of a sudden. So in UPS, the energy is generally stored in flywheels, batteries, or supercapacitors, when compared to other immediate power supply systems. And UPS has the advantage of immediate protection against input power interruptions, and it has very short on battery run time. However, this time is enough to safely shut down the connected apparatus, that is computers, telecommunication equipment, etc., or to switch on a standby power source. So UPS can be used as a protective device for some hardware which can cause serious damage or loss with a certain power disruption. So uninterrupted power supply power source, UPS, battery backup, and flywheel backup are the other names often used for the UPS. So the available size of UPS units ranges from 200 volt ampere which is used for a solo computer to several large units up to 46 MB. So as I was discussing, that UPS can be used as a protective device for some hardware which can cause serious damage or loss, which is sudden power disruptions, and uninterruptible power source, battery backup, and flywheel backup are the other names often used for the UPS. And the available size of UPS units ranges from 200 volt ampere, which is used for a solo computer, to several large units up to 46 MB. Okay, now what are the roles actually of UPS? So major roles of the UPS. So when there is any failure in the main power source, the UPS will supply the power for a short time, and this is the prime role of UPS. In addition to that, it is also able to correct some general power problems related to utility services to varying degrees, and the problem that can be corrected are voltage spike, that is sustained over voltage, noise, quick reduction in input voltage, harmonic distortion, and the instability of frequency in bands. Once again, I'm repeating this major roles of the UPS. That is when there is any failure in the main power source, the UPS will supply the power for a short time. So this is the prime role. Basically, this is the prime role of the UPS, and in addition to that, it is also able to correct some general power problems related to utility services to varying degrees. Mainly the problems that can be corrected are voltage spike, that is sustained over voltage, noise, and quick reduction in input voltage, harmonic distortion, and the instability of frequency in bands. So these are the major roles of UPS. And what are the types of UPS? Generally, UPS system is categorized into online UPS, offline UPS, and of course a line interactive UPS. So other designs include standby online hybrid, standby ferro, delta conversion online, etc. So once again, I am repeating this types of UPS. Generally, the UPS system is categorized into online UPS, offline UPS, and line interactive UPS. And other designs include standby online, hybrid, standby ferro, delta conversion, online, etc. So, and let's start with offline UPS. Basically, offline UPS, this UPS is also called standby UPS system, which can give only the most basic features. Here the primary source is the filtered AC mains, that is shown in this figure, solid line. Okay, so solid path. When the power breakage occurs, particularly the transfer switch will select the backup source. So that is shown here. So this is the main line, surge suppressor, mains, filter, then transfer switch to the load. This is the main. So when actually a power breakage occur, this DC voltage, but we can clearly see that the solid that when the power breakage occurs, the transfer switch will select the backup source. You see here this backup source. This is the backup source. Okay, so when power breakage occurs, this will select this backup source, and as a result, so load will be, say, getting supplied. Okay, so let us come to the point. So actually, so we can see clearly that the standby system will start working only when there is any failure in the mains. Okay, so if this is off, so standby switch come here. So this is the process battery. Actually, battery is being charged AC to DC. So this is charging path. Then battery will convert DC to AC and supply to the load. Okay, so when power breakage occurs, this DC voltage is converted to AC voltage by means of a power inverter and is transferred to the load connected to it. So this is the least expensive UPS system, and it provides surge protection in addition to backup, and the transfer time can be about 25 milliseconds, which can be related to the time taken by the UPS system to detect a utility voltage that is lost. This is the block diagram. So this is actually main supply. So this is surge suppressors. Any spike or surge will be suppressed by this block. Then filter, the harmonics is there, so it will be filtered. This is the going to the load. Now suppose the power supply is getting, say, interrupted. So then this transfer switch will come here. Okay. So during supply and without any interruption, so this dash line will show the battery charge. Battery will be charged. So this is AC. This is AC to DC converter, that is rectifier. So that will supply this battery for charge. And when power breakage will be happened, this battery will supply to this inverter unit. That is DC voltage will be converted into the AC, and this AC will be supplied to the load. So, and hardly it will take few milliseconds, so 25 milliseconds or something like that. So that's is the offline UPS. So in the and then you will come to discuss about the online UPS, then line interactive UPS and its applications. Now once again this portion will be discussed in the next class. So once again I am repeating this say UPS portion. So what is UPS? It is basically uninterrupted power supplies. It is defined as a piece of electrical equipment which can be used as a immediate power source to the connected load when there is any failure in the main input power source. And in UPS the energy is generally stored in flywheel batteries or supercapacitor, that is shown here. When compared to other immediate power supply systems, UPS has the advantage of immediate protection against input power interruptions, and it has a very short on battery runtime. However, this time is enough to safely shut down the connected apparatus, that is computers, telecommunication equipments, or to say, or to telecommunication equipments, or to switch on a standby power source. So UPS can be used as a protective device for some hardware, which can be can cause say actually so UPS can be used as a protective device for some hardware which can cause serious damage or loss with a sudden power disruption. So uninterruptible power source, battery backup and flywheel backup are the other names often used for UPS. And the available size of the UPS units ranges from 200 volt ampere, which is used for a solo computer, to several large units up to 46 MVA. So, and major roles of UPS are when there is any failure in the main power source, the UPS will supply the power for a short time, and this is the prime role of UPS. And in addition to that, it is also able to correct some general power problems related to utility services to varying degrees. And the problems that can be corrected are voltage spike, that is sustained over voltage, noise, quick reduction in input voltage, harmonic distortion, and the instability of frequency in mains. And the types of UPS, generally UPS systems is categorized into online UPS, offline UPS, and line interactive UPS, and other designs include standby online, hybrid, standby Faro, delta conversion online, etc. And also we have discussed today, that is offline UPS. This UPS is also called as standby UPS system, which can give only the most basic features. And the primary source is the filtered AC mains, that is shown in the figure in the solid path. And when path breakage occurs, the transfer switch will select the backup source, that is shown in the dash part line in the figure 1, and thus we can clearly see that the standby system will start working only when there is any failure in mains. And in this system, the AC voltage is first rectified and stored in the storage battery connected to the rectifier. And when power breakage occurs, the DC voltage is converted into AC voltage by means of a power inverter and is transferred to the load connected to it. And this is the least expensive UPS systems, and it provides surge protection in addition to backup. And the transfer time can be about 25 milliseconds, which can be related to the time taken by the UPS systems to detect the utility voltage, and that is lost. And this is the block diagram, as I told you. This is for main, and this is for backup, that is for the UPS systems. So it provides such suppressor, filter, and then to a load. And this is the energy stored in the battery. This is from AC is being converted to DC by the rectifier, then stored in the way, and during breaking power interruption, this battery DC voltage will be converted by this inverter to AC, and it is supplied to the load. So that's all about this today's discussions. And so today we have discussed about the UPS and the static circuit breakers, that is AC circuit breakers and DC circuit breakers, as well as the interactive part of the UPS and the offline UPS systems. And then the next class we will discuss about, say, other UPS, that is online UPS, then line interactive UPS and UPS applications. So that's all today. Thank you all for your patient hearing. Hope you have enjoyed the sessions, and if you have any problem, you will contact me, as I told you and say earlier also. So thank you.